So let's start with static caching during installation of the service worker. Now keep in mind, the service worker is only installed if it changed. So only if you release a new version of the service worker. Otherwise, it will not get replaced. Now for that reason, the installation phase of a service worker is a great place to cache some assets which don't change that often, like your app shell, the toolbar, your basic styling, that might not change every second. Now also your main scripts, these might change frequently, but you would deploy a new version of your application anyways then, so you can update your cache in this case too. But it doesn't change every second, or it's not user-created dynamic content or anything like that. So for that, we'll use the cache API, and we have our index.html page, let's say, for a given route, for our main route maybe. We load a couple of assets there, like our main script, our main styling, and an image, and we want to cache these files. Now we do that during service worker installation, where we get access to the cache API, and can then store these files in the cache. This is what we'll do now. These files can then later be fetched even if we have no internet, and since we put them on the cache right during the installation of the service worker, they will be available from there already on the next page visit of the user. So this is the earliest possible point of time we can use to store our files in the cache. Back in the project, let's implement this static caching of our app shell. Now, as we identified, the app shell is basically our index.html file in the root folder. This is the starting page we're probably landing on if we just visit our main page. There is also all these scripts we're using here, because these scripts are required for this page to work correctly. And of course, these styles we're importing. This is our style sheets, but also that style we're importing from this CDN here. That's from the Material Design Lite package, this theme we're using. The same is true for the icon set here and these fonts. These are all in the end things we want to cache right at the start of our application, because they define how our main page looks like, our app shell looks like. Now in a single page application, this is even more important, because in our app here, we actually have different pages, though they use a lot of shared assets. So the other page also uses the app.js file and so on, and uses the same styling. So what we cache on our main page is also available there, of course. On single page applications, you don't even have multiple pages though. So there especially, what you cache on your main page is available throughout your entire application, no matter which URL the user visits. So therefore, we should cache as much as needed, but not everything, because you don't want to overpopulate your cache. For one, the browser might clean it up if it runs out of space, if it gets too occupied, and therefore you want to be conservative about what you put into the cache. And on the other hand, if you cache too much, there is the danger of loading content from the cache, even though for the given resource, an up-to-date version from the network might be more appropriate. But we'll talk about different caching strategies later. For now, let's store these files in our core or in our cache during the installation event. So for that, in the install event listener, we want to access this cache API. And we do this by accessing caches. This simply refers to the cache API, caches, and then open. With that, we can open a new cache in there. Now, when I talk about the cache API and a cache in that cache, you can simply have a look at it on the application tab in your developer tools. You have your cache storage down there. And in that cache storage, where you have only one per given page, per given domain even, there you can open multiple sub-caches, so to say. And this is what we can do with the open method. If it already exists, it will open it. If we would try to open a cache which does not exist yet, it will create it. However, keep in mind that I told you that in a service worker, we work with asynchronous code because it's running in the background and it's event driven. Therefore, the install event doesn't wait for this to finish by default. It would just see install event, log this, trigger this operation, and continue. And this can lead to huge problems because the service worker installation finishes, you might have a fetch listener, you do fetch a resource, and you try to get it from the cache, even though your caching operation here hasn't finished yet. Therefore, we can use event, so this event object we receive in this function here, and there the wait until method, which means what it sounds like. It simply waits until a given operation which has to return a promise, and cache is open returns a promise, until that is finished. And it won't finish the installation event before that is done. So this is what we have to do here to ensure that we're done with our cache preparation before this continues. So again, I pass cache is open here, and I just structure it over multiple lines to make it easier to read. And this in the end returns a promise. We can listen to the promise result with then, but wait until, thankfully, we'll wait until we're done in the then block as well. Now, before we do something in the then block, we have to decide which cache to open. And you can give your cache any name you like. Here, I'll name it static, or because it's our static cache, our static assets which don't change that often, and which we pre-cache right at the start. You could also name it pre-cache, whatever you like. Then inside the then block, we execute a function like in all then blocks, and we get an argument passed into it by that open method, so to say. So once it's done opening the static cache, or creating it in case it didn't exist yet, it will pass a reference to that cache to that function we execute here. Now in that function here, we now can add content to the cache, so add files to the cache. So here first of all I want to console log something. I'll add my service worker prefix again to make clear that we're inside a service worker, and I'll say precaching app shell, because this is what I want to do here. And now we do the actual precaching. For that we can access the cache, and there we got a couple of methods we can access. The methods you can access can be found on this MDN documentation page I showed earlier. We have match, match all, add, put, delete, and keys. Now I'll walk you through these throughout the course. Basically what we can do is match allows us to see if our cache contains a certain key. That's why we pass a request here. Remember, requests are the keys in our cache. So we can see if a certain resource is stored. And match all simply does the same for an array of matching requests. Add allows us to add an item to the cache, and add all allows us to add an array of items. So basically spares us to have multiple add calls. Now put is a little bit like add, but add does something else. Add will execute the request first. So it will send the request to the server to get the response and store the response, which you need to do. Put is appropriate if you send the request in the service worker manually. We'll see both in this course. Add and add all are typically the things you want to use for pre-caching, because you don't want to send the request manually there. Put will become more important later. Delete allows you to remove an item from the cache, of course, and keys allows you to see which keys you have in that cache. So basically which, requests you have in there stored as keys. So this is the API, and again, you will see that throughout the course. Here, add allows us to add a new resource. And as I said, with add, the service worker will go ahead, send the request to the server, get that asset, which it of course needs to be able to store it, and stores it all in one step. And what we pass here simply is the URL we want to send a request to. Now, for example, if we want to store the app.js file, we pass the path to that file, seen relative from our web root on, because we're on our local file system here. So we can say /source/js, and in there, then the app.js file, this file, app.js. So this will make a request to that file, download it, and store it in the cache. Well, let's actually see if that works. For that, I'll save this, and I'll go back to our application. Now, keep in mind that the browser will update the service worker whenever it changed by only 1 byte or more, of course. So we changed the service worker, so it will try to install the new one. And we saw that before. If we just refresh the page, the new service worker enters waiting state. Now we could click skip activating, or of course the way which always works, the cleanest way, is to simply close the tab and open a new one. Now the new service worker is installed. And during that installation, you can see it pre-cached our app shell. It's printing that log. We can now have a look at it. on the application tab. Here, cache storage. You should now have an arrow to expand it. Otherwise, click refresh caches. There you see this new cache named static. That's the name we set up here. And inside that cache, you see one key value pair pointing to the app.js file on our domain. And the response is okay, but it actually is the complete response, including the asset itself. Now, if we go to network and tick offline, let's reload the app. You see, it still fails because we're not fetching this file we cached. Still, we would be able to do so, and we will do so in a second. So let's fetch our cached asset in the next lecture. Oh, and by the way, if you're wondering why we just stored one file and not all the files I mentioned that would belong to our app shell, just because I want to get there step by step. We are not done with precaching yet.